2.5 billion years ago, our corner of the galaxy was nothing more than a vast cloud of dust and gas, a stellar nursery. Triggered by a shock wave from a nearby supernova, this cloud began to collapse in on itself, giving birth to a star we now call the Sun. As the Sun ignited, the remaining material flattened into a spinning disk. In this chaotic disk, tiny particles of rock and ice collided, clumping together through a process known as accretion. This was the brutal cosmic process that built the planets. One collision at a time. Around 4.5 billion years ago, a massive object, roughly the size of Mars, slammed into the young Earth. This cataclysmic event, known as the giant impact hypothesis, reshaped our planet forever. Our planet, a fiery sphere of molten rock, was one of these protoplanets. For millions of years, it grew, sweeping up debris and gaining mass with every collision. But the most significant event was yet to come. The debris from this collision was flung into orbit, where it coalesced to form our moon. The period following this collision is known as the Hadean Eon, a name derived from the Greek god of the underworld. Our planet was a hellscape, with a surface of boiling magma constantly reshaped by volcanic eruptions. There was no air as we know it, just a thick, toxic atmosphere of carbon dioxide and water vapor. For hundreds of millions of years, Earth endured the late heavy bombardment. A relentless barrage of comets and asteroids pummeled the planet, delivering not only destruction, but also a crucial ingredient for life: water. The water vapor released from these impacts and volcanic activity began to accumulate in the atmosphere. Slowly, over millions of years, the planet began to cool. The water vapor in the atmosphere condensed, falling as rain for what may have been thousands of years. This relentless downpour filled the lowest basins, creating the first vast global oceans. These ancient seas were not the calm blue waters we know today. They were a murky, chemical soup, rich with the ingredients for life. In the darkness of these oceans, far from the sun's light, a new kind of energy fueled change. At deep-sea hydrothermal vents, hot, mineral-rich water spewed from the ocean floor. Here, under immense pressure, simple organic molecules began to form and combine. The exact process remains one of science's greatest mysteries, but in this chemical crucible, these molecules somehow organized themselves. They formed primitive membranes, capable of containing a unique set of reactions. These were the very first protocells, the distant ancestors of all life on Earth. From a swirling cloud of dust, through a cosmic collision and a hellish bombardment, our planet was forged. And within its primordial oceans, the spark of life was lit. This marks the end of Earth's first chapter and the beginning of an epic story of evolution that is still being written today.